probability for junior beginners. And so we're first going to start off with probability and what it is and the formula and all of that. Then we're going to move on to learning about the probability of coins. And then we're going to move on to the probability of dice. These are dice from Las Vegas, because dice is obviously important there. And then we're going to move on to cards. And finally, we have our vocab. So we're going to start off with probability. And you might be wondering, what is probability? Well, probability is the chance of basically for anything to happen. It can be like the chance of it's going to rain today. Well, today's pretty sunny because it's like April, but that's probability. So the probability of that would probably be 0. If the probability of something is 0, that means there's no chance at all. If it's somewhere close to 100, if it's a percent, or somewhere close to 1, then that means it's probably going to happen. But anyways, probability is everywhere you go, especially if you're in Las Vegas. Probability is basically everywhere you turn, especially in casinos. Don't go into casinos, you're too young. Anyways, basically probability, there's a simple formula that you should know and you should use, and it's basically defines all probability. It is the number of favorable outcomes, which is the number of outcomes we want. For example, rain is an outcome, over the number of total outcomes. I wouldn't know what the total number of outcomes for weather would be, but let's say it's either raining or it's sunny, then it'd be 2. And the probability of it raining today would be 1/2 or 50%, but it's April, it's not gonna rain. Anyways, another example of probability is, let's say I have a coin, and the probability of it being heads would be 1/2, because there's 2 possible outcomes, either heads or tails, and there's one thing that I want, which is heads, so 1/2. And one last example is if you're rolling a dice and you want to know the probability of rolling a multiple of 2. Well, there are 3 multiples of 2, 2, 4, and 6. So 3 favorable outcomes over 6 total outcomes, because 1, 2, 3, 4, 5, 6, because it's equally likely for any of those to happen. Now let's move on to coins. And right here I have this purple goblet, or just a lunch container, and we're going to use it to flip coins because I probably won't be able to throw it up and catch it. So usually in coins there are 2 outcomes, either heads or tails. It is highly unlikely for it to land on its side, but if it does, that would be cool. And the probability of getting heads or tails would be 1/2, because heads or tails, 1 event for each, and there's 2 total events, so 1/2. But what if I do 2 coins? So I have 2 quarters here, and let's say I want 1 head and 1 tail. So let's shake it up, and wow, I rolled it. I have, this one's a head, probably can't see that, and this one's a tail, which is cool. But basically, let's say I want that. Well, let's list all the possible ones we can have. We can have heads, heads. We can have heads, tails, or tails, heads, and then tails, tails. These 2 are different because the coins are not the same. They're technically different. For example, if I were to have heads on this coin and tails on this coin, it's different from having it flipped. Having tails on this and heads on this. So that basically, I want 1 head and 1 tail, and this one has 1 head, and this one has 1 tail, and this one has 1 tail and 1 head. Basically the same thing. So 2 possibilities out of 4. And you might have learned simplifying fractions already, but if you haven't, what you get when you simplify is you divide top and bottom by 2. So you get 2 divided by 2, 4 divided by 2, to get 1/2. What if I want 3 coins? Well, here are my 2 quarters, and then I have a penny. So let's say I want 3 the same. So let's shake it up. It's very loud. And that's actually really surprising. I have a heads, I have a heads, and I have a heads, which is actually surprising. Well, that's one of the many outcomes we can get. So for this one, let's list all the outcomes. We can have heads, 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 which is what I just got. I just dropped my penny. Heads, tails, heads, 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 tails, heads, tails, 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 heads, tails, 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 heads, tails, heads, heads. Well, there are 2 ones that have the one that I want, and then there's 6 total. No, wait, that's 8. I can't count. I should probably watch it first. Anyways, that's 2 over 8. And then when we simplify it, it becomes 1 over 4, not 1 over 3. So that's that. So you might also be wondering, well, why do I use probability? Well, here's why. Let's say we're going to go back to this problem. And I want 1 head and 1 tails. That means every time I flip 2 coins, it means there's a 1/2 likelihood of me getting what I want. So, meaning if I flip 2 coins twice, at least one of them is going to be what I want. Well, it's highly likely to be what I want. And if you do that infinitely many times, it's eventually going to give you 1/2 or somewhere pretty close to it. Same goes for 1/4. Every 8 times I flip it, around 2 of them will be heads, 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 or tails, tails, tails. Or every 4 times I flip it, one of them would either be heads, 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 or tails, tails, tails. Now let's move on to dice. And in a dice, there's 6 outcomes. And the reason is there's 6 different things you can roll. You can either roll 1, a 2, a 3, a 4, a 5, or a 6. You probably can't see that, but those are all the things you can roll. And every time you add a dice, the total number of outcomes multiplies by 6. And the reason why for that is because for each of those 6 outcomes, the next dice brings you 6 more outcomes, as in 6 times 6. For each of those 6, you get 6 more. So 6 times 6. And then if you want more, times 6. And onto how many ever you need. So, what's the probability of me rolling an odd number? Well, let's have my dice. And let's just do a little try run. I got a 5. And that's pretty obvious because the probability of rolling an odd would be 3 because 3 odd numbers over 6, which is simplified to 1/2 because you divide both by 3. So that's the probability of rolling an odd number. And what about an even? Well, here's the thing about the even numbers. Well, a number is either even or odd. It can't be in between unless it's a decimal. But we're talking about whole numbers here. So it's either odd or even, and the total thing is 6 over 6 or 1. So you do 1 minus 1/2 because those are the probability of getting odd to get 1/2. Because like I said, it's either odd or it's even. So let's try another way of finding even. Well, there's 3 total even ones, 2, 4, and 6, and 6 total ones. So divide both by 3, and you get 1/2, which is your answer. What about multiples of 3? Well, how many multiples of 3 are there? There's 3, and then there's 6. So it's going to be 2 over 6, which is 1/3. What about 2? Well, there's 2, 4, and 6. Basically all the even numbers. So that's 3 over 6, which is 1/2. And finally, what about multiples of 2 and 3? Well, multiples of 2 are 2, 4, and 6. Multiples of 3 are just 3 and 6. The common one is 6, meaning 1 over 6. So now let's move on to our final probability part, which is not coins, cards. So for cards, basically there are 52 cards, and I have all of them here today, except for the ace of spades, but instead I'm going to use a joker. So usually, if there's a probability problem, it's going to use a standard deck. And a standard deck is when you don't have any jokers. Like I said, I'm just using the joker so I can replace it for the ace of spades. And in those 52 cards, there are 4 suits. There is diamond, there is heart, there is clover, and there is lastly spades. And in each of those suits, there are 13 cards, and that goes from, let me just find a good deck. That goes from the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, the jack, the queen, and the king. And the jack, king, and queen are called face cards. So let's say we want to use probability. Well, what would we do for probability in cards? Well, first we're going to shuffle it up a bit. This is how I shuffle. So basically, they can ask you ranging from what's the probability of getting a red face card, or what's the probability of getting the ace of spades, to what is the probability of finding a red card. So let's do a couple of examples. So let's start off with what's the probability of getting a red card. Well, in those suits, we have 4 suits, and 2 of those suits are black and 2 are white. The 2 black ones are the clover and spades, I just dropped a card, and the 2 red ones are are diamonds and hearts. So if I wanted to find the probability of red one, all I have to do is 2 over 4, because each suite or suit has the same number of cards, meaning 2 over 4 is 1/2. So the probability of getting a red card is 1/2. So let's just draw a couple of cards to see what happens. The first card I get is red, so 1 for 1. Second card is also red, 2 for 2. Also red, 4 for 4. Also red, that's like 6 for 6. And then finally we have a jack, which is black. So if we continue to do this, we would eventually get an equilibrium, meaning equal amount of 1/2. So let's try another example. What is the probability of choosing the queen of diamonds? Well, in one deck, there's only 1 queen of diamonds. So the probability would be 1 over 52, meaning the chances of finding the queen of diamonds on your first try is very, very low. And I got the king of hearts. I was super close. So let's just do 2 more tries and then we'll move on. Queen of diamonds. I got it on my second try. Anyways, the probability is just a relative measure, meaning it's not always true, but it just shows what's most likely about to happen. Like me getting that queen of diamonds on my second try was highly unlikely. Or me getting all those reds, that's highly unlikely. I would usually, if this was like an actual thing, it'd be red, black, or black, red, black, red. There'd be a probability of 1/2. And let's try one last example. What is the probability of getting any 3? Well, for this, there are 4 3s, 1 from each suit. There's a 3 of spades, 3 of clovers, 3 of diamonds, and 3 of hearts. So if there's 52 total cards, and only 4 3s, that means it's 3 over 52, which is 1 over, what's 52 divided by 13? I think. There's 4 3s, and 4 over 52 is 1 over 13. Another way you can do this is you know that there's 1 3 in each suit. So 1 over the total number of cards in a suit is 13, so 1 over 13 is also your answer. Now let's move on to our very last topic, which is vocab. And vocab is going to be a bit more common now because it's important to know what I'm actually saying or talking about because you'll just be confused. So in probability, when you're saying how likely an event is going to happen, there are 5 things you can say. So impossible. Impossible means no chance, it's never going to happen, only in your dreams. Then there's unlikely, which is less than 1/2 but greater than 0, meaning there's a really small possibility it can happen, but it can happen. And then there's even chance, meaning the probability of it happening is 1/2, meaning there's an even chance of it happening and not happening. And then we have likely, meaning it's more than 1/2 but less than 1, meaning it's probably going to happen, but there are some times when it doesn't happen. And lastly, we have certain, meaning it's going to happen no matter what. It's always going to happen. And then we have some more probability terms, which is when we're actually doing something. So an experiment or trial is basically an action it's when you're trying to test something, but you don't know what's going to happen. So it's like me flipping a coin. I don't know if it's going to land heads or tails, or it's me throwing up dice. I don't know what number it's going to land on. Then we have a sample space, which is basically all the possible outcomes of the event. If I have a coin, that means the sample space is heads or tails. If I have a dice, it's 1, 2, 3, 4, 5, 6. If it's cards, it's any of the numbers in the deck. And then there's the sample point, which is basically one of the things in the sample space. For heads, it can be, for the coins, it can be heads or tails. For the dice, it could be 1 or 2 or 3, 4, 5, or 6. Not all of it. And finally, there's an event, which is what happened. For example, it could be throwing up 1 coin and getting heads, throwing some dice and getting 2, picking a card and getting the queen of diamonds. Those are all events.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!